So, I'm the last person standing between you and flying home or getting beers or getting drunk. And I'm going to talk today about monitoring in an infrastructure as code age. Small part about myself. Ages ago, I used to be a software developer. I wrote software in all kind of crappy languages, Perl, PHP, C, Java, whatever. And I kind of became an operations person out of necessity because I was the guy who was always racking machines and clustering them and making sure they stayed up. That evolved that today my role is I'm evangelizing DevOps. I'm one of the people who started DevOps Days back in Ghent in 2009 together with Patrick. I'm the CTO, and CTO in this case stands for Chief Trolling Officer. You might have seen a piece of that when I was trolling Luke during his keynote. He has to syntax check his t-shirts. So we do that because I like to challenge people into figuring out better ways how to learn and educate themselves. Like Jesse told us this morning, you need to figure out and stimulate people so they can learn from themselves. You might also know me from my blog title. The Google guys talked about it. Everybody knows it today. Everything is a fucking DNS problem. I don't have all the solutions, but, well. And that's pretty much about me. So, the DevOps movement. Who knows what DevOps is? You guys sure? Lots of people ask me for my definition of DevOps. And I could come up with myself having a definition. But John Willis and Damon Edwards, they basically did that work for me. In their podcast, they figured out that DevOps, it's about one keyword, CAMS. Culture, it's about how an organization lives, how they work with their teammates, how they work together, all that kind of stuff, and how they deal with failure, how they basically culture. What's an organization built on? It's about automation, and automation, that's what this conference is about. Using Puppet, using tools to make sure that we don't have to do the boring work and that we can actually focus on the fun part. And automation in all parts, in building, in testing, and then basically we talk about infrastructure as code. It's also about monitoring and metrics. And if you combine infrastructure as code with monitoring and metrics, then you get to a whole new discussion. And it's about sharing those experiences. And a lot of people have been on stage in the use case room and here talking about how they deal with new infrastructures, scalable infrastructures, and they have been sharing their experiences. Yes could also stand for security, and I'm kind of getting a fanboy of that idea, that we also use the S for security. Because if we do this, then we can actually also build much better and more secure platforms. But monitoring. Monitoring is usually something that comes up at the end of a project. We need to monitor this. We need to, but you're out of budget. You don't have any time anymore. And then you're stuck. So what happens is that people figure out, well, we need to do this hackish way, and we have a real problem doing this. So monitoring sucks. John Vincent, I think it's already 2 years ago, when he started a thread on Twitter with the hashtag monitoring sucks. And to me, basically, the monitoring sucks movement it's a sub-movement to the DevOps movement. It's a bunch of people who are trying to focus on that specific area, and we're trying to figure out how to improve monitoring, how to build a better way to monitor infrastructures. We've got a GitHub repository where we pretty much try to list all the tools that were available with their benefits, where the source code was. We started doing hack sessions, trying to figure out how to solve the problem and start working together and getting different teams from open source projects together. And then, about a year later, at DevOps Days Rome, Ulf Manson from Recorded Future, he gave an ignite, and he said, I don't hate monitoring anymore. Monitoring doesn't suck anymore. He had his kids draw up some pictures, and we have a lot of people who since then have found a newfound love for monitoring, and we call it now monitoring love. So that all in the area of a year. So we fixed it, right? Who loves monitoring today? I don't think we fixed it. So let's get back to what infrastructure as code is. My vision of infrastructure as code is that you module your infrastructure and you use code, Puppet, to build a platform that is fast, reproducible, and scalable. And it basically means that, I hope this works, you have the lower part here, the part which is completely in blue, and that's a part which I can rebuild over and over and over again. And if a platform which I need to build for a customer, that's the core part, the blue part. There's the operating system in there, there's a middle layer and the databases in there, there's the queuing stuff in there, and then on top of that, there's the application layer. And that is a fixed set of things for a platform. Then I take a part on top of that, and that's the actual environment configuration. That's where I give the platform an identity. That's where tools like Hera come in, and where we actually say, look, this platform, this is actually the development platform. This platform, this is acceptance, this is production. Or this is data center number 27 or data center number 33. And these things, you need to be able to version, and you need to be able to reproduce. You can add some business rules, and then the red part on top of that is the actual customer data. I can imagine that for a lot of you, the sizes are a bit different, that there's much more customer data than actual code. But if you keep out the customer data, this stuff you can constantly reproduce. You have basically disaster recovery for free because all of this should be infrastructure as code. It should be reproducible. And then the only thing you need to do is take backups from the other parts. So the strange thing is that if you explain this to people who have been doing infrastructure work for a while, they say, yeah, sure, that's right. But if you start explaining that to a manager, to developers, they don't get that. And what they don't get is that for years we've been basically figuring out how to get developers to use continuous integration, to use tools, to start using testing, to start using version control, and to make sure that they started building software and quality software that we could manage in production, but we just accepted that somebody went onto a machine manually, logged on there as a user, as you to root, and then change the value of a platform, and we accepted that? Who still accepts that in his production platforms? Why? We have the tools out there that allow us to do different. So infrastructure as code is code, and we need to treat it as code. We need to use version control. We need to put in quality checks. Sam just told about using Puppet-lint, using all kind of tests. We need to put in, to make sure that the quality of the code we produce is good enough. So we need to do continuous integration on that platform, up to the point where we can actually do continuous delivery. And we need to be capable to build our core infrastructure, the middleware deployments, the full stack. Open source tools allow us that. Proprietary tools, well, they make it hard. We need to be able to do automated continuous application development in line with the infrastructure, tested on the whole platform, and get security in there, because it's code. We can get everything in there. And then we can, if we can do that, have also the monitoring of the applications configured. But it's still hard, because monitoring still sucks, and lots of the monitoring tools we have, well, lots of monitoring steps are done manual. People log onto a GUI, click left and right, and figure out, well, this might work. 20 new hosts are added, or 1,000 new hosts are added, and the monitoring system does not reflect reality. It does not reflect the changes of the machines that have been added or have been removed. And lots of times they only look at hosts. Sometimes they look at a service, like is Apache running? Is this socket open? But it pretty much never look at the actual business functionality of a service. They look at maybe is a vhost defined, but they don't look into if this is an application that is responsible for billing, can I actually bill my customers? Does the billing engine still work? And eventually that leads into manual change and it leads into chaos. So why do we do that manual part still while we have a lot of things around? Well, a lot of those problems are the tools. I think it's time that we as a community forget about tools that have no stable APIs. I mean, there's plenty of tools out there that over the couple of years have been trying to get an API, but they never got it stable. Or tools that are still focusing on a way too strong GUI, like, hey, this is nice and fancy, but I can only see like half of the stuff I really want to see. So scrolling over 20 pages of hosts before you actually see something, that's not something I want to do. So tooling is one thing. The other thing is that a lot of organizations, they have only one setup for monitoring. The only thing they monitor is production, because they only have the capacity to configure that one cluster that's monitoring production, and they only do that. And we need to think about monitoring as soon as possible in the development cycle. Start monitoring from development. Monitoring, not only your development environment should you monitor, but you should also have a development environment for your monitoring tools. Take that to acceptance, take that to production, and make sure that you can actually build a feedback loop as fast as possible in your platform. And this might sound like a repeat, but what we want then is the old Unix philosophy. Small tools that are good at doing what their job is, and we want to combine them. We want to be able to have a system where we can, on one side, collect data, we can transport that data and transform it, and we can then analyze that data, visualize it, and act on certain events that happen when we start learning from that data. So when we want to do that, what we need to do is build a baseline, build a platform which is going to work for certain parts in the monitoring infrastructure which we want to monitor on every host. And we need to figure out how to collect that. We need to define checks, and we need to update the monitoring tool. So let's talk a bit about tools. Can you guys in the back read the tools? And guys in the front can't read the tools. OK, whatever. Basically, the blue part here on the left are all kinds of different ways to collect metrics, to collect information. You can have Java applications that have GMX exposed. You can have log files like Apache or Tomcat log files. You can have system metrics which you collect using collectd or different tools. You can have Puppet reports where you can learn from. You can have Nagios. And all those tools, all those metrics, you can ship using, for example, GMX trans. If it's pure GMX, you can ship log files with Logster or ship them to Logstash. You can ship, for example, collectd metrics using collectd carbon to Graphite. And all these tools in the middle, they're a transportation medium. And then here, basically, we start learning from those metrics. We start basically collecting them, visualizing them, doing calculations with them, and then doing all kinds of other stuff with it, visualizing them. And that's a complete chain of tools which we can build. So we build a machine, we build a service, and how does that look like in code? It's going to be trivial for you guys. This is Puppet code. It has a class Apache. We configure all the Apache stuff. And then we say, look, we are running Apache on all the nodes. I'm running Apache. I also want to have collectd collect the Apache metrics. On all the hosts, basically, we want to rotate the log files. We want to ship them. And I also want to have my security rules in place. And that's a simple piece of code which you should have in your infrastructure. You're defining Apache, and together with Apache, you define all the dependencies, like collect metrics from my Apache. Ages ago, we set up Apache, and we forget about the metrics. And now, each time you're going to deploy Apache with your Apache class, you're going to get the metrics. But that's metrics. That's only one part. So now we want to see and learn from those metrics. So what tools are out there? There's a lot of tools out there. But if you start looking at the ones that are really matching the requirements we have, like I want to be able to use a tool that can configure them, that can automate the configuration, where we have text files, where we can actually not use an API because the API would be unstable, and where we can also export those data from. Then there's a limited number of tools that are still around that are usable. We talk still about Nagios, or Bernd, how do you spell Icinga? Icinga, all right. Or Sensu, and that kind of tools. And you figure out, isn't Nagios still not dead? No, it's not. I like Icinga because it has a vibrant communities. Those guys throw really good parties in Nuremberg. And Bernd can teach you how to pronounce it, which is much easier than pronouncing my last name. Ask Luke. There's Puppet modules for that, which can really configure it good. And you can use all the power of Puppet to actually do that. Who knows how stored configs work? OK, that's an awful. That's not a lot of people. Breeze, are you here? Can you come up and explain them stored configs? Ah. It's your picture. Stored configs basically are part of Puppet where you export a resource on one side. It's going to store that in a database, preferably PuppetDB for performance reasons. In one manifest, you basically say, look, this is a resource which I want to be visible on other nodes. So it's going to export that, it's going to say that on Puppet Master, it's going to store it in DB, and then when another node runs, it's going to basically collect that information. It's going to collect that information which you have exported on the Puppet Master on the client. In code, that looks like an exported resource has two adds, and to collect them, you basically use the spaceship, and you get it. So that makes sure that each time you boot a new node, you install an Apache, and you have a vhost defined in there, and you export that resource, it's being stored inside PuppetDB. It's being stored inside a central storage location where another tool, in this case Icinga, can actually query that. So you have 1,000 nodes. There's going to be 1,000 entries from where you can actually configure your monitoring setup, and it's going to generate that code for you. You don't have to maintain that yourself. Now, if you delete those nodes, you need to clean up. Magic doesn't happen. You really need to, if you deprovision your nodes, you really need to do that. So, as an example, basically, a Icinga server, it's going to collect default host, the services, and then on a client, you basically say, look, this is my node, and I have this service which I'm exporting, and here's the collection. Pretty easy. This is default usage of Puppet exported resources. They still exist. Use PuppetDB, because otherwise, performance-wise, you will be necked. In one of the last slides, I'll actually be pointing to alternative approaches for this, but for a lot of people, this is going to work just fine. So if you want to monitor a virtual host, it's the same approach. You define a check, you export that check, and then on your Icinga server, you're actually going to collect those checks and learn from that. So that's still an old school tool, right? That's still a tool which has been around for a couple of years. So lots of people talk to me about, hey, have you seen this new fancy tool? It's called CheckMK. Who knows CheckMK? Who likes CheckMK? I also like CheckMK. I love it because it does auto-detection of a lot of stuff that I don't want to configure manually. It figures out about my RAID setups. It figures out about my disks, about my file system layouts. It does multiplexing, so it doesn't check all the time, and there's only one connection going over the network. And it has a really nice way of forecasting that my disk is going to grow and it's going to flood. But on the other side, I absolutely hate CheckMK, because it does not understand infrastructure as code. It wants to take charge of configuring stuff for me, whereas I'm saying I'm in charge. I'm writing the code. I know how my infrastructure works. And CheckMK generates my Nagios config, and I don't want it to generate that config. I know which hosts I've deployed. It shouldn't be telling me. I like the small parts which I don't want to generate, but it takes way too much away from me. And it does auto-detection. Yeah, sure, it can figure out it as Apache installed, but can it figure out that I've defined 5 vhosts and there's an actual business application with business functionality which it needs to monitor? No. You could write a plugin for it, but I kind of already have that. So the problem with CheckMK is that in an infrastructure as code age, it just doesn't work because it's trying to do the work which you have already done. You have defined your single source of truth, and CheckMK tries to basically write over that. So it's about what you want to monitor. It's about, I'm monitoring a service, not just Apache as a service which is running, but the actual business functionality, and CheckMK can never help me there. And if I'm writing a check for a Puppet module, if I'm writing a check for a service for a business functionality, I can actually deploy that together with my code, with the application. So we've taught developers on how to write checks so applications work. We've told them, you have a Java application. This is what I want from you. I want to have a status. I want to have information on to make sure that the application is done. And you feel like I filled the whole cycle. I have an application. I can deploy it. I can monitor it. So it's done, right? You teach developers this by telling them that their definition of done should be monitored and in production. Who's had the discussion about the definition of done with their developers? How long does that definition of done discussion usually take? A week? 2 weeks? 3 weeks? Longer? A year? Forever. So let me give you my definition of done. Yeah. It's never done. I'm one of the guys who likes, I'm a big fan of Agile, and a lot of people think that DevOps is a reaction against Agile. I'm not one of those people. But I think there's things that Agile needs to get rid of. And one of the things they need to get rid of is the definition of done. You can use it to actually get to the point where we learn stuff. But if you get rid of the definition of done, you still need to figure out one thing. Is my end user dead? Is the application still being used? And that brings us to the next part. That brings us to metrics. That brings us to actual application usage metrics. Like this thing. How many times have we deployed Puppet? Are we still using Puppet? Because if we don't see any deploys, this is, by the way, the draw as infinite, which we do when there's a package with Puppet manifest being deployed. I'm not using Pulp because that's too slow. That's a discussion I wanted to have with Sam, but I was in the backstage, so I couldn't ask questions. So, hi, Sam. Let's have beers later to discuss this. The deploy frequency of the application, life cycle of the application, that's all kind of things we need to monitor. We want to figure out, and trust me, this is a really important thing. How many users are we still having on the application? I've had setups where we were migrating an application, and we were actually going to the developer like, so, can we migrate? Can we shut it down? I don't know. What do you mean you don't know? Well, we send out a mail. Yeah, but is anybody still using it? I don't know. So how do you figure out? Oh, I just do a tail -f on the log file. If there's nothing for 15 minutes, it's fine. Or a better one is, well, we just firewall it off, and if people complain within 5 minutes, then it's... But what do you mean? You as a developer should care about the fact if people are actually using your software. So I ask developers to actually build in metrics so that we can figure out how many users are still actively using their site. You also want to know stuff like response times, if it's slow, if it's fast, the throughput, and whatever usage. Also a good one, how many times have you restarted PHP FPM? Because developers do that behind your back. And you want to be able to give those developers metrics and self-service metrics. Who likes Graphite? Who does not know what Graphite is? So Graphite is an awesome tool. Graphite is basically the ultimate storage tool for your metrics. We used to have Cacti. Cacti didn't scale. You needed a full-time DBA to actually manage Cacti. That's kind of not productive. Graphite is as simple as sending a timestamp a key value pair to port 2003 of your Graphite server. And it creates immediately a new graph. And that graph has an API, because it's a host, it's a graph, and you can do all kinds of things with it. You can build it. You can give that back to your developers, and you can have your developers start playing with it. And then you can start learning from those graphs, and you can start do all kinds of maths on those graphs. And you can start learning that it's different behavior from yesterday, or you can start figuring out that, well, we know disk space, disk usage is growing. I don't care about disk usage is growing. Disk usage is always growing. What I do care about is a sudden peak in disk space growing, or a sudden peak in Java heap space usage. And I want to be able to also alert on that part. So one of the tools we have there, in the big picture before, I showed GMX. I showed GMX trans. We have setups where we export specific parts of our Java metrics. We configure an RPE check Graphite. And there we allow Nagios to actually check what's happening on the metrics on Graphite. What has been happening on that metric over the past half hour? For example, this is a Hornet-enqueue application. Hornet-enqueue is one of the queuing systems. And with queues, you know that if there's stuff which stays too long on a queue, you have a problem. So this is an actual functional application where we have a check Graphite config file. We get our stuff from Hera. We know where Graphite is. We send the information, the metrics, from GMX trans to GMX trans, which flushes this to Graphite. That's an exported resource for the GMX trans server. It collects the data from our local machine, but it's configured in a manifest of the local machine, but it's actually the GMX server which is going to implement that code. Then we also define a Nagios check on the host where the service runs. We export that, and on the Nagios server, we actually run the check which is going to talk to the Graphite server to see how long have I been away. So we include these, we export that stuff, and the check is basically the URL of Graphite, the render, the target, and then we want to know over the past 30 minutes if there were still 2,000 messages on the queue, that's fine. But if there were 20,000 messages on the queue, well, Houston, then we have a problem. And we actually build based on the graphs, based on the metrics that we collect from different sources, we build checks. And we have them automated. If I'm deploying 20 Java applications which are exposing their graphs, I also have 20 different metrics and 20 different checks which are automatically being deployed. There's no extra effort in configuring those. It happens automatically. That's what infrastructure as code is about. You write this stuff once, and you run it everywhere. Sounds like Java, right? So this is an API. Developers like to play with APIs. Developers like to build on top of this. They want to see their own metrics. They actually come to the point where now they can build a platform where they know how many users they have, and they actually can have that visualized. But then there's a different breed of people, and that's the managers. And they don't know how to use the API. So for them, you need to give additional tools. For them, you need to basically build dashboards yourself. We use Gdash a lot. Gdash allows us to have a templating system where we can have Puppetized templates, and that's still, actually it isn't a work in progress anymore. I need to update that slide. Where we, basically when we deploy new systems, we automatically update the dashboards. So if we deploy a new platform, there's a new dashboard which is being generated, which has the information that management people and other people care about. So we get self-service dashboards on one side and automatically generated dashboards based on the infrastructure code we've written. So if we build out a new data center, the dashboards are being generated automatically. Also, based on pipelines, we are still figuring out how to syntax check the G-Dash templates, but it's already much better than doing this manual. So what do we have in place now? We can deploy infrastructure. We can deploy the monitoring together with that infrastructure. And we can also deploy the metrics information that people are looking after and visualize that for them. So what's up next? What are you saying? This in a cloud environment. This is very host-centric. Yes and no. Because if you dynamically grow more nodes, you can also remove them. That's cleaning them out of PuppetDB, and that's basically your decommissioning. If you decommission a node, there's one script which also triggers thingies. There's a slide which is gone, because basically the slide that was in this presentation, I figured, was the slide about if you really have a flexible setup where hosts appear and disappear within the time frame that your Puppet runs are happening, then you want to go to a different approach, and that different approach for me would be Sensu, where you basically have a different module, where we have services that are subscribing to what they need to monitor, do the checks, and don't report if the hosts are gone. And that was actually a slide, but yeah. So it's a different approach, but also there you can export those resources and configure all those things automatically. There's also Puppet modules available that allow you to do that. But depending on how fast you scale, this still works for up to 1,000 nodes. If you go beyond that, then you are having different issues. But the thing that's actually up next is to start taking all that information you have and making sense out of it, learning from it, like figuring out what's going to happen next if you've seen all these things, like really doing machine learning on top of that, or figuring out patterns and reacting on patterns. And there's a bunch of tools out there, which I call homework, that allow you to do that. A lot of them have been written by the Etsy people. I think there's also some stuff from, who did Dusk again? Was that GitHub?
Yeah,
it was Jason, yeah. Sometimes I get them mixed up. So the two first ones are actually done by the guys from Etsy. Dusk was just last week or the week before published by Jason. There's also other tools where you want to send events to and figure out and learn from them. And there's also, if you don't want to use exported resources, there's a tool which is allowing you to do PuppetDB external. And from there, you basically can build your Icinga or Nagios config. And that's going for the next step. But the important part is that we now have created a feedback loop. We have now created a platform where when we deploy it in development, in acceptance, in production, we immediately give developers a platform where they can learn from, where they can actually see what's going on the platform. So we have a much faster loop to fix things, and much faster loop to actually make new checks. Because that's the thing, if stuff breaks, the next thing you're going to do is implement a new check. And rolling out a check this way, it's going to be one commit, and it's going to be rolled out on all your nodes. And in the old way, it would have been manual work for a couple of weeks, and you would have forgotten a bunch of things. And that's a new way of thinking if you are doing infrastructure of code. No more manual work, just like we've been automating the rest of Puppet. That was pretty much my message to you today. Might have gone a bit fast, but I guess you don't mind, as now there's beer. So, questions? Yeah, please walk up to the mic so we can hear you.
When you're going through this process, you end up with a lot of little tiny nodes. how does that, how have you seen that affect, like when you get a bug, how does that affect the pipeline? Is it more stable, or does it actually cause cascading failures, and how do you mitigate that?
I'm not sure if I'm getting the question, because you said if you go to this process, you get more nodes.
Okay, so with this process, you basically have instead of having 1 or 2 or 3 layers, big modular layers that are doing your monitoring, your metrics collection, all this stuff, it looks like you have a lot of small little, you're stringing a lot of small tools together to get the job done. Does that increase the likelihood that you're going to get some kind of cascading bug or cascading failure, or have you actually seen that actually lessens that?
So the question is, because we're using different tools, if that would accumulate to more and complex failures rather than solving it. What we've seen is that we've been collecting more and more metrics, and we've been learning from them more and more. And we can actually, because we have more metrics, predict that stuff is going to happen. And our next step is to start automating that. So the small parts are all much stabler than one big bloated system, which would have internally still have a bunch of small parts. But when that part fails, it's completely failing. Whereas now, if there's one collector which doesn't work, it's just one small component which is gone, and not everything.
Okay, thank you.
Yeah. More questions?
What do you think of the tool called Zabbix?
What do I think of what?
The tool called Zabbix.
Zabbix.
Yeah.
Okay. So, can I have the slides back? Yeah, sorry. It was on my slides down there. It's one of the tools I like to forget. It's one of the tools. I was actually involved in writing the Zabbix book ages ago. During the process of writing and reviewing the book, the API changed twice. We had setups of about 200 nodes, and we pretty much with Zabbix had the same problem as with Cacti. We needed a full-time DBA to manage them. So unless you are a small or medium enterprise with less than 100 nodes, I wouldn't recommend it anymore. If you're a small shop, I think it's a perfect tool which shows you everything in one part, but it doesn't, for me, fit when you're doing infrastructure as code. At least that's my experience.
Okay, so what if you have developers addicted to the JMX instrumentation in their code?
Can you repeat?
So follow on. So we're using Zabbix with a lot of Java JMX instrumentation deep in the code, and it integrates well. So what would you replace Zabbix with that still has JMX connections? So
JMX trans, for example, allows you to pretty much get everything from the JMX and transfer that to Graphite or to Ganglia, and then you basically have the same metrics and even more fine-grained data where you can work on than Zabbix has.
So the elephant in the room is always, let's talk about monitoring and then forget to talk about alerting and how we actually wake people up at night and how we take that next step. Because the issue I keep running into with this stuff is I can get this far, but how do you keep it to the point of the NOC doesn't just go nuts when there's a fucking DNS problem? And my favorite is so we have a DNS server problem, or in our case, they reload the Active Directory DNS servers, and hey, Nagios just shit itself because it can't access the web servers because it's accessing them via DNS. So how do you deal with the alert overloading and adding that additional logic?
So one of the things that we're doing, for example, is Icinga has this concept of parenting. And we have basically all our physical machines, they're the parent of the virtual machines. There's also a chain which we automate where we know that dependencies between hosts. And we define these dependencies in code because we define in code that that application talks to that database. So those relations, at least for the parenting, we have pretty much automated them. Our different environments also have different, our development environment, for example, does not send out alerts. We see them, but it's not being sent out, it's only being sent out as mail, not as text. And that's all HERA parameters which we use, depending on which environment, we get different notifications. That part is definitely a part where we're still investing in development of the Icinga module. But for example, the parenting stuff we use. So if there's one physical machine goes down, then we don't bother about sending out checks for all the virtual machines that are running on it and the servers that are running on it. But it definitely still not is a solved problem. When we were having the monitoring love hack sessions in our office in February, one of the discussions we had was actually applying a business intelligence tool on top of that, or even doing a business workflow management tool to figure out how to learn from those things and get alerting based on that. So the question I asked before, we solved it, is monitoring solved? It's definitely not solved yet. There's a lot of work that needs to be done, but this is a basic part where you can build on top of. Yeah, next question.
It's just in response to the previous question, I suppose, and a bit of a plug for an open source project that my company is sponsoring. It's called Flapjack, and it sort of handles the problem that you're getting at, but not via parenting, but by sort of automatic tag-based roll-up. So you might have a look at that. It's called Flapjack.
Yeah, so Flapjack should have been on my to-do list. But since ever Linz, they basically used an old project name for a different project, lots of people got confused. I told him that already when I had a chat. But yeah. More questions? Or do you guys want beer? Beer and what? Beer and questions. Yeah, I'm actually used to stand up with a glass of beer in Belgium, but okay, well, thanks a lot.